Yes, Mr. Gorski, I know you're closed, right? Okay, okay, because the student needs he needs a computer to check out and take home. Okay, so he's gotta go up there then. Okay, okay, thank you. Can't be a mistake. She is open, but you here. You go to the front office.
All right.
Miss Jennings?
Yeah.
That's who we go. She's the one that goes. Getting tired. Okay, let's go up there. That's where you go. This message is cleaned up, okay?
a big mission?
Actually, we did get a call, but not so fast. No mission yet. They just want the suits back.
Man, I don't get it. Well, we'd be perfect to go into space. I mean, we know everything there is to know about the planets and the solar system. Go ahead, quiz me.
How far is Jupiter from the sun?
778 million kilometers.
You are correct, sir.
Must be defective equipment.
Hey, wait a minute. Maybe NASA's planning a top-secret planetary space mission for us.
Yeah, that's it. Well, we better get prepared.
No kidding. We need to find out, what's really out there.
Could we live on another planet someday?
Do other life forms really exist?
And the mother of all questions, how do you go to the bathroom in these things?
Good question.
Did you know our solar system is 50 trillion kilometers long? So if you were able to walk from one end to the other at regular walking speed, which is like 5 kilometers an hour, it would take about 342 million years. And that's without stopping for sleeping, eating, or bathroom breaks.
Okay, first things first. Where do we start?
Formation of the solar system, of course. Crucial for any planetary expedition.
Right you are, my friend.
Many scientists believe our solar system started out as a cloud of dust and gas called a nebula 4.5 billion years ago. As the nebula spun faster and faster, it collapsed onto itself and flattened like a pancake, spreading out over trillions of kilometers. And at the center, our sun began to take shape.
Right. The sun is formed. And we're not talking small potatoes here. This sun is huge.
It's beyond huge, and a solar system is nothing without a sun. After all, the word solar means sun, and all the planets, moons, and other space objects that circle around the sun work together in a system, the solar system. It takes Earth 365 days, which is a year, to orbit or revolve around the sun once. Not only that, Earth is constantly spinning or rotating. It takes Earth 24 hours to complete one rotation.
Excellent. It rotates while it revolves. What else?
There are 9 planets in our solar system. Each one differs in size and distance from the sun, and each one has its own distinct characteristics. Plus, there are a total of 60 moons in our solar system.
Oh,
They revolve around many of the planets, while the planets revolve around the sun.
And this is the part that gets me. Only one moon revolves around the Earth, right? And some of the other planets have like 15 moons in their orbit. Bunch of moon hogs.
You know what I like? Asteroids. They're like mini planets, except planets are spherical and asteroids are irregularly shaped.
Oh yeah? Well, I like comets. Big clumps of ice, most about a few kilometers wide and covered by dust. Kind of like a big, dirty snowball. Hey, Stan,
Yeah?
what's your favorite planet?
Inner or outer?
Doesn't matter.
Doesn't matter. Come on, they're so different. The inner planets are solid and rocky, and most of the outer planets are made of gas, have rings around them, and are much, much bigger. How can I pick a favorite?
'Cause that's the game.
Okay, let me think about this then. First, there's Mercury, a dry ball of rock covered with craters, kind of like our moon. It's the second smallest planet in the solar system, and because it's closest to the sun, it takes the shortest amount of time of all the planets to complete its orbit. Only 3 Earth months.
I guess since Mercury is the closest planet to the sun, it's also probably the hottest. I bet you need a sunscreen with an SPF of like 1 billion to live there.
Actually, Mercury isn't the hottest planet. It has no atmosphere, so there's nothing to keep in the heat at night. Even though temperatures can be 400 degrees Celsius during the day, it can be minus 173 degrees Celsius at night. Now, second from the sun is Venus. This is the hottest planet in the solar system. Surface temperatures are a scorching 500 degrees Celsius.
That's 900 degrees Fahrenheit.
Hot enough to melt lead.
I bet on Venus, you can make a grilled cheese sandwich in 0 seconds flat.
Pay attention, please. I want to talk about the thick clouds that cover the planet. They're not at all like the ones on Earth. These contain sulfuric acid and carbon dioxide, elements that cause heat to stay trapped beneath the clouds. On Earth, we call this the greenhouse effect. Even though our clouds are much different from those on Venus, some heat buildup still happens on Earth.
You see, when fossil fuels like gasoline, coal, and oil are burned here on Earth, extra carbon dioxide gets added to the atmosphere. So scientists worry that too much carbon dioxide could one day lead to an atmosphere like Venus. And who needs that?
You know, Malcolm, if this mission comes through, we'll be able to see Earth from hundreds of miles up.
Hey, if anyone is out there, can you see me? I'm waving!
Okay, Malcolm. On Earth, we're 150 million kilometers from the sun.
That's 93 million miles!
And the only planet in the solar system that we know can support life. For life as we know it to survive, there has to be liquid water, moderate temperatures, and a breathable atmosphere.
We've got water, no problem. About 70% of the Earth's surface is covered with it.
And the planet's moderate temperature range allows water to exist as a solid, liquid, and gas.
Also known as ice, water, and water vapor. Just a little factoid I thought I'd throw out there.
Our atmosphere is also incredibly unique. It protects us from the sun's harmful rays and from space debris like meteors. Most importantly, it contains the oxygen we breathe. All these conditions need to be in place for billions of years for life to evolve.
Okay, so after Earth comes planet Mars, also known as the Red Planet. It's 228 million kilometers away from the sun, which equals 141 million miles.
Right. The surface is the color of rust due to iron oxide in the soil. Violent dust storms can kick the red dirt up into the air, making the sky look pink. Even though there's no liquid water on the surface, scientists have discovered lots of water locked up in polar ice caps. And did you know that a day on Mars is just a little longer than on Earth? That is, it takes Mars just a little longer for each rotation. Here you can see that the orbit of Mars is much wider than Earth's. So it takes nearly double the time to get around the sun. About 687 Earth days equals 1 Mars year.
If you were 14 years old on Earth, you would only be about 7 years old on Mars. You would still have lived just as long, but a year on Mars takes twice as long as a year on Earth.
Hey Stan, have a favorite planet yet?
Dude, we haven't even gotten to the outer planet, and we still have to go through the asteroid belt. And any astronaut worth his salt must be able to navigate turbulence. Look out up ahead! Whoa!
Ladies and gentlemen, this is your captain speaking. We're experiencing a bit of turbulence. Please return to your seats until I have turned off the overhead sign. Thank you!
To get to the next planet, we have to pass through hundreds of asteroids. Most asteroids travel in an orbit called the asteroid belt, which separates the inner and outer planets.
This is your captain again. It seems as though we have safely navigated the asteroid belt. If you look out your window to the left, you'll notice that we're approaching the first of the outer planets. You are now free to move about the cabin. What do you think it would be like to see Jupiter up close? I mean, it's over 1,000 times bigger than Earth.
We probably noticed right away that it's not solid like the other planets. The Voyager space probe flew by Jupiter and took pictures which showed that it is made up of swirling gases and has a faint ring around it. We can check out Jupiter's Great Red Spot, a giant windstorm as wide as 3 Earths, as well as the 16 moons that orbit the planet. 5 are large and round, while the rest are small and irregularly shaped like asteroids. One of the moons, Io, is full of active volcanoes. Another, Ganymede, is the largest moon in the solar system, as big as the planet Mercury. And Europa is completely covered by a frozen, salty ocean, and they have liquid water beneath the ice. I wonder, liquid water is a key ingredient to support life as we know it. So could we survive on Europa?
True, water is one of the things we need to survive, but we also need an atmosphere with oxygen so we can breathe. Since Europa doesn't have an atmosphere, I wouldn't plan on vacationing there anytime soon.
After Jupiter comes Saturn, about another 1 billion kilometers away. Saturn is best known for its incredible rings. From a distance, the rings appear solid, but look closer and you can see how they're mostly made up of billions of rocky snowballs. Some are small enough to hold in your hand, and some are as big as a house. Saturn is made up of gases like Jupiter, and it's also the lightest planet in the solar system. It's less dense than water. So if Saturn could fall into a bathtub, it would float.
That would be one giant bathtub.
Then there's Uranus, 7th planet out and 2.86 billion kilometers from the sun.
Which converts to 1.78 billion miles.
Uranus is also a gaseous planet with a ring system, but it's a bit different from the rest of the outer planets we have just seen. Uranus lies on its side. In other words, one of its poles always faces the sun. It doesn't take Uranus 84 Earth years to orbit the sun. One of the poles gets 42 years of constant sunlight, while the other gets 42 years of absolute darkness.
Man, I couldn't imagine living in the dark for 42 years. I still sleep with a nightlight.
Travel yet another 1 billion kilometers and you will approach Neptune, the 8th planet from the sun.
Neptune is really out there.
No doubt. Neptune takes almost 165 years just to orbit the sun once. It's a blue planet, but unlike Earth, the blue is not liquid water, but methane gas. Neptune has some of the fiercest winds in the solar system. This is the Great Dark Spot, which is similar to Jupiter's Great Red Spot, except the winds blow even faster, up to 840 kilometers per hour. Last but not least is Pluto, the solar system's smallest planet, about 1/6 the size of Earth. You know, some scientists have called Pluto a double planet because its only moon, Charon, is so close by, and it's so large, about half the size of Pluto. Also, unlike the previous 4 gas planets, Pluto is solid, and almost everything on its surface is frozen. Temperatures are as low as minus 212 degrees Celsius,
Which is minus 350 degrees Fahrenheit.
That's because Pluto is far, far away from the sun's heat and light. It takes Pluto 248 years to orbit the sun just once.
Wow, that means if I lived on Pluto, I'd have to wait 248 Earth years just to have one birthday. Okay, we've been through all the planets. Now are you ready to tell me which one is your favorite?
Hands down, it would have to be Earth. Between the extreme heat, cold, and gaseous states of the other planets, I think Earth is pretty cool.
I agree. Hey, watch out for the...
Can I change my answer? Did you know the ancient Greeks believed that Earth was the center of the universe and that everything revolved around it?
My mother says I'm the center of her universe.
Earth's amalgam. I'm talking the year 140 CE, and a Greek astronomer named Ptolemy. Ptolemy published his findings and data on the stars and planets, which endorsed the popular theory that Earth was the center of the universe, while all other objects, the sun, moon, and stars, revolved around it. This view of the Earth's place in the solar system is called the geocentric theory, named so because geo means Earth. Ptolemy's theory made perfect sense at the time. After all, we can't feel the Earth move, and we can see the sun cross the sky from east to west throughout the day. It took about 1,400 years for that theory to be challenged. In 1543, Polish astronomer Nicholas Copernicus presented a new diagram of the solar system. He showed that the sun was the center of the solar system. Earth and everything else revolved around it.
Let me guess. This is called the sun-centric theory.
Close, but actually it's called the heliocentric theory. Helio is the ancient Greek word for sun. What Copernicus couldn't explain, though, was how the planets stayed in orbit instead of shooting off into space. 200 years later, in 1687, English scientist Isaac Newton found the answer. He established that a planet's motion around the sun is the result of two things: inertia and gravity.
Want to see how inertia and gravity work together to keep the planets in orbit? Grab a tennis ball, some string, a rock about as big as the ball, a tape measure, a plastic tube like from a ballpoint pen, tape, and scissors. First, measure and cut about 1.5 meters of string.